We've got Carrera with us now. Hey, Eero, how's it going?
Hey, good. Thanks for having me.
Oh, it's our pleasure. How's everything with you?
Good, good. Well, as good as things can be in the current situation, but pretty good.
Wonderful. So for the folks who do not know, Eero is one of our trainers with the HITV Sec Train, and he would be having a training thing next month or in 2 months' time, I believe. But the main reason he is here is to talk about threat intelligence and AI and all that good stuff. Eero, why don't you give us a background about yourself before we start?
Okay, I'll try to keep it brief. But I've been around 20 years and rounding up a bit, rounding down actually. I'm old on this industry. I started in F-Secure doing malware analysis, malware research. Then spent some years working with Halvard Flake in Dynamics and the whole team there, and VirusTotal. And the last 10 years I spent at Google doing large-scale malware analysis and then focusing more on threat intelligence and automating threat intelligence analysis with the kind of tools you have at a place like Google. So, I've touched on different parts of the whole InfoSec spectrum and had a lot of fun doing it.
Nice. So you said the tools they have at Google, right? So what would be the main difference between a TI team in Google and maybe a normal MNC or a company that's trying to mature their TI program?
That's a really good question. I think a big difference revolves around how normalized at a place like Google the use of large scale databases is. And I think when I was working there and I talked to people outside, within Google, you take for granted that you're going to just put all of your data, whatever that data is that you use for threat intel, in a database. And all of your data can be billions of rows, terabytes and terabytes of data, and just query it as many times as you need instantly, pretty much. And as you may imagine, that makes certain kind of workflows incredibly fast and powerful, while the only thing that you have is just a fancy database. But that's such a incredible difference to have that foundational tooling at that scale. It's funny because it doesn't really mean that you have to push, crazy machine learning or any especially fancy techniques. You just have very basic tools at an extreme scale are so powerful. Of course, then you can build on top of that. But I would say that's a pretty key difference, just how much of an enabler a good infrastructure can be.
Right. And they always say, right, with the tools, you need the expertise of the people to operate it. So, I mean, what kind of background or expertise are we talking about here?
As for the team, you mean? So the team, actually, the threat analysis group was I think I was lucky to end up working with such a team because I think it was probably has parallels in other organizations at the level of Google. But Google being Google, it was when I joined a team of around 20 people, and we had people coming from different government intelligence agencies. We had some of the top reverse engineers and vulnerability researchers in the world. We have amazing threat intelligence analysts with domain expertise in the cyber world. So it was, of course, you join the tooling with the level of skills and the focus there, and it was in a way easy to get some good results. So it was a varied and extremely skilled team, and it was quite a privilege to work there for the time that I did.
Nice. And I think with TI, the main importance is the freshness of the data, right?
Helps a lot, but I wouldn't actually discard the fact that having some sort of history and background is useful as well. Of course, there is limited use to having indicators from 10 years ago. But having a database that keeps some context, maybe for a few years, sometimes some actors reuse infrastructure for a long time. So of course, fresh data is relevant to study current threats and current ongoing attacks. But if you want to be able to read a fuller picture of threat actors across time, how they evolve, keeping that historical context as much as possible, as much as you can afford it in your databases, and as well as doesn't make the intelligence workflow more complex, I think there is value in that.
Okay, and how does AI or ML play a part in this?
In a way, I think I sometimes may sound a bit as not a disbeliever, but skeptical about AI and ML. While I'm teaching a training on that, so it's kind of maybe a little bit funny. But the thing is, because I grew, my background is as a hacker. As a teenager, I was cracking software and always learning things by myself. So I came to machine learning in the beginning with a lot of skepticism, thinking, this cannot do magic. That's the truth. It cannot do magic, but it can automate a lot of things. And if you're a person that, once you understand the problem, you'd rather be working on something new, machine learning is a fantastic way of actually, in a very principled way, teach or have the computer learn some patterns in the workflow that you're doing or in the data to actually then have the computer do it repeatedly. So you don't waste your time and you can move to something else. So I think within the threat intelligence scape and, be it malware analysis, be it actually analyzing and working with intelligence techniques, be it, glorified automated automation, glorified automation, machine learning, or, full on AI, deep neural networks. There's a broader spectrum of, complexity there. But there are pockets, there are specific niches where many of these techniques can be applied and will, boost and empower your team. It will free resources. The human resources are always the most expensive, getting skilled people and then making good use of those people. So applying machine learning, applying automation in the right spots frees humans to do the right thing and invest their brains in the interesting parts of the problem. So I think that's the interplay of using humans well and have the machines do what the humans don't want to do, and it's routine. I think that's the ideal case.
Right. I see you came just in time for the AI part, Dylan.
Of course, bro. I won't miss the AI, baby. How are you, Hero, man? Damn nice to see you, brother.
Yeah, man. It's been a while. Nice to see you too, man.
Yeah. Good times, man. I don't know. It's been more than 10 years probably, I think, since I last saw you, but feels like that anyway.
I think it's been like that, yeah.
But talking about the AI, man, when it comes to modeling, right, like the feature extraction side of things, right, like how do you even begin to decide what's going to be modeled, what you're going to model your deep neural networks, right? Like how are you going to decide on the feature, right? That's always been my main thing, as in, cleaning the data is a bitch. Everybody hates that.
I'm very happy that you use such a graphic language because yes, entirely agree. And actually, you just hit the spot. I don't want to reveal too many things from my training, but we're going to definitely be touching on that because I think, and actually, I've sat in pitches for a startup where, the big boss was selling the idea. We have lots of data, we have the best, and now we put it together, magic happens. As a practitioner, kind of me wanting to raise my hands, maybe not that easy, because it's exactly that. You will have the best machine learning algorithms, you will have expertise. Still, you'll spend 90% of the time there is such a thing as debugging your data, because you realize that the data is not as clean as you thought. Always happens. Then you'll have to go back if your workflow allows you to. What data was wrong? Why is it wrong? Was it entered incorrectly? Was it labeled incorrectly? There's a broad spectrum of things that can be wrong with the data. Was it acquired incorrectly? A problem with the sensor? A problem with the tool that generated the data? Different tools will generate alarms or trigger or generate logs for different events, not necessarily in a consistent way. And if you throw it in the same bucket and try to learn from it, you're not. Or you're going to learn really weird things. So having a very clear workflow from data to classification, to the result of the pipeline, and being able to go, whenever you find cases that don't make any sense, being able to go back to what data generated that labeling, that verdict from the system, critical. And that's why personally, the times we have applied machine learning to threat intelligence, generally we've shied away from the class of algorithms that tend to be more opaque. Like neural networks are fantastic for some specific tasks like image recognition, but they are knowingly hard to debug in that if a classification is wrong, it's very hard to ask the machine learning algorithm, the model, why did you do this? While there are a class of algorithms, the simpler ones, if you will, but still extremely powerful, logistic regression, Bayesian networks, random forest, where you can actually go back to the algorithm and see what weights were wrong, and from those weights, see what data actually, what were those inputs, and then actually iterate. And I think in these kind of workflows, that iteration, that being able to go from bad classification to what the data, fixing, understanding the data better, and have that loop a few times, that's where it gets you to something that you can actually deploy.
Yeah, and also, I mean, the fine-tuning the parameters as well, parameter fine-tuning in itself is an art, you know what I mean? Like, trying to get everything to converge properly and not overfit.
Yes, entirely. So sorry that to your original question about feature extraction and feature engineering, that's a mix of, having good domain expertise in your team, because if you have, and I've seen cases where you get really good machine learning engineers and throw them to a problem where none of them have a lot of domain expertise, and sure, they're going to make the algorithms fly, but they don't understand. They will not understand in the beginning the intricacies of the data. Is it something coming from a sandbox? What does it mean to have this API call on this argument? How can you debug that? So having somebody that is an expert on understanding the data helps. So that helps, that feature engineering, that first connect the dots of like, this should help, this shouldn't. And then, yes, you need that as well, expertise in machine learning to understand the behavior of the algorithm. Is it fitting right? Is it overfitting? If you're using a neural network, is it deep enough? Do you have enough parameters to encode this kind of information? Do you need, two classes? Do you need a multi-class classifier? All of those things is something that where you actually need the domain expertise in machine learning as well. So having this kind of teams with the expertise well combined, not trivial.
Are there already Jupyter notebooks and stuff that people can just fire up and then just pump in some whatever XLS or at least structured data or some sort into it so that it start doing some features?
There are, and depending on the tools that you go, that can always be a first attempt, right? Just to get some of the, get TensorFlow, get maybe something simpler like SciPy Scikit to start with, and, load the CSV file, load the Excel file, apply some of the basic algorithms, see where they fail, understand this. And I'm talking really simple. Maybe some of them don't take continuous features. Maybe some of them don't take discrete features. Understand that. Understand why that algorithm doesn't do that. And why do you want to do it? Do you need discrete features for this? So, I started knowing nothing about machine learning. So you use like regression, classification, clustering. All of these are different ways of, different outputs of machine learning algorithms. So, you have some kind of drag and drop things that you can try, but you need to develop as well the expertise and some expectations and intuitions about what each of the major algorithms can output to already start on the right track.
What about, have you looked at capsule networks? That seems to be the new shit, right? With LSTM stuff combined with deep.
Yeah.
So
I have not. Most of the data sets that I worked with personally were not necessarily time dependent in the way that an LSTM, LSTMs, I think, could have worked well. Never tried that, but in the case of analyzing behavioral traits on application over time. So I never, the specific problems where I worked were actually recognizing code to 8 massive disassemblies. So at Google, we disassembled all the software that, we got from all of the sources. So doing that at scale, being able to recognize all of different compiler patterns, so where to start disassembling is actually a problem that just either doesn't scale that far, right? So we had to attack it on our own. So we built some models to recognize code, and that worked surprisingly well. But it was a very specific niche problem that gave a lot of returns. But, who needs to build a machine learning model to disassemble? Not that many people, but at Google with it. And then machine learning around threat intelligence, around actually ranking evidence. So again, that was not a very specific an instance of a problem where anything from the family of deep networks was applicable. I know they were being used for the standard image recognition, OCR in documents, and extracting text. It's like, works. But not necessarily for, I don't remember instances in our workflows where we were using them in the intelligence analysis workflow, because as well, the decisions that were made there, about some infrastructure being related to an actor, sometimes then we needed to take actions on that infrastructure. Maybe it means sinkholing it. Maybe it means something different. And we need to be able to debug those actions. If lawyers later come and say, why did you do this? We can't say the machine said so. We need to, I wish. We need to say, we need to be able to say, we use some techniques, but this is the trail of evidence. So we need algorithms that could provide, the decision as well as why that reasoning was reached. So it can be justified. So when the stakes are high in the decision, sometimes that conditions the kind of algorithms that you can use.
Sorry, just let me pause you there for a quick second. We just got Dennis, who joined in as well. Dennis is nice. A fellow trainer with IT SecTrain and HITV SecTrain, who is talking about championing security programs, if I'm not wrong. Hey Dennis, how's it going?
As usual, it's quite spontaneous, but anyway, we are here.
Exactly, yeah. So just feel free to jump into the topic, right? We're just keeping it casual. So if you have anything to input, we can go with that. We'll obviously come to you in a short bit as well.
And I listened a little bit about some models that you train something, you're trying to extract something, and that it's a quite hot topic because you need to protect machine learning by itself also. So that's why I think in the industry, you need to keep your model safe. You need to keep the personal data. If we're talking about the personal data in data sets, so we need to protect it. So maybe next training will be also how to protect things that protect us.
That'll be an interesting one.
Dennis, you make an important point, because last year we had a paper about reversing the black box models, right? Because like everybody says AI is like a black box, right? Like you just put some data inside it and then some answer comes out and you're like, why did it come up with the answer? I have no idea, bro, but that's the answer that came out. But being able to reverse those models is cool because then you can learn from it. But it becomes an IP issue when you start reversing like self-driving cars and figure out how those cars are making the decisions on whether they, go faster, go slower, whatever, right? Like, so the reverse engineering of AI models in itself is like a super, super interesting area. And I think right now, a lot of machine learning practitioners, they only release partial code, but the actual, you want the weights. Because like Google has TPUs and they've got like amazing amount of resources, right? I've got a stupid ass NVIDIA GPU. I can't do anything with that, right? So, but at the end of the day, that fully compiled model, right? Like with the weights, that's what everybody wants. And then the retrainable layer. So everything at all the way up to the last layer. And then I just have to retrain just a little bit, but folks don't release that. So yeah. How, man? Give us some, bro.
That's the secret sauce. No, but it is true. It is an actual problem, and not just about reverse engineering the model itself. In some instances, that can be the problem, but as well, sometimes it's the oracle problem. If an attacker can actually guess why the model knows what it knows, maybe it actually is a window to the data that you have about them. And in many instances, I've been in places where you can't really publicly admit to a certain verdict or judgment, just because that will tell the adversary what you know about them. And it's more valuable to keep that secret and keep collecting information or tracking them than actually revealing it. So I mean, not just the model itself by the intellectual property that it encodes, but actually because of the information that it may reveal, you're able to acquire is worth protecting. So as well, that depends what the model, if it's trained on images that are publicly available, probably not so important to protect. But if a lot of, private information goes into that model, user private or company private information, it becomes really valuable and something you have to protect, even protect at the level of limiting the amount of inferences you allow other people to do with it, because then they could query and kind of like learn everything that the model knows, which is something you don't want them to do.
Or another attack vector, if you have some decision-making processes that relies on your network. If you can affect the process, you don't need the internals. You just need to affect it somehow to change the decision, and that's it. This attack was successful. So it means that decision-making process is quite important also.
Very true.
And I mean, if you can influence the output of what the model is going to detect, then the operator is going to take that as gospel, right? The machine is going to output, hey, no threats here, bro, everything all good. And yeah, the operator is going to say, yeah, it's all good, right? The model came out and say, fine. So then nobody's going to verify it, or you'll have the reverse where, false positives also could be another false flag, basically, right? You can't false flags in the data because the model is going to pick up for that, or it's kind of biased towards that, so you can then hide your stuff below it, right? It's interesting, man. I love the AI stuff, man.
Yeah, and actually just recently learned about this class of problems as well, where the attack is actually on the computational part of the inference. Like the models, when they process the input data to make an inference, there are paths that are more expensive at the level of the weights and the part of the model that is invoked to actually make the inference. So depending how you construct the data, you can actually overload or lead to extreme costs at the level of making the inferences, depending how you present the data. So you can, do a denial of service of a model just by presenting, extremely expensive to evaluate examples. Of course, that requires being able to, have an understanding of how that model works and what's expensive for it, but probably you can just do by trial and error, end up in finding those little things.
Yeah, that's going to be quite interesting, and it's almost impossible to solve against, because how the hell are you going to, how do you model that threat? You know what I mean? How do you even say what is actually valid and what isn't, right? Like if somebody's just going to be sending very small bits.
Yeah, you can, but probably you can limit, talking with some distance from understanding the actual problem here, but probably you could try to, the same way as you deal with SIP bombs, right? Or you used to, or you try, just, some things you try to, decompress them, go over a certain size, kill the process. So in a way, you kind of limit the number of resources per job, per inference job, so that if it goes crazy, then you can assume maybe an attack is going on and just but I don't know. Actually, I don't know if the inference infrastructure is built, TensorFlow and everything that is built at cloud scale even consider such scenarios. So probably they don't really have a way of, dedicating only 0.0001% to each inference and otherwise kill it. But they will have to think about that eventually. So there's a lot of definitely, it's a new paradigm and there are a lot of security vectors to it.
Unless you're Google, right? Because then you don't really care.
Yeah, we solve everything. Yeah, we never have any problems. Yeah.
Just process it, bro. It's fine, right? We have TPUs and good. But do you actually have access to a TPU? I mean, personally, as in, can you compile code on TPUs and your models?
Yeah, inside the company, some models, maybe the newer models were more limited to the specific teams that have the highest computational need. But in general, there were several generations of TPUs available, and you choose where to run on normal CPU, TPU. Sometimes you just say whatever is available, and yeah. From that point of view, Google is quite amazing.
Cool, man. Hey, so that is what you've been working on, bro. Like, I mean, I'm guessing you're not into the AI stuff. What have you been working on, man?
In the context of machine learning, it's pretty fun that you know that some frameworks, like open source frameworks for model training and processing, like Akumos, they have the multi-distributed multiple components inside for operations of the model, for training the model, for I don't know. No, I'm not an expert. I just look at this as a pen tester, and a lot of things, a lot of toys inside this big environment. And sometimes, if your model is successful, you need to touch some endpoint to make some decision. Like the model decide that is a cat. Please touch this endpoint. So, and sometimes you can identify vulnerabilities in these systems, like server-side request forgery, for example. And you can touch without any trainings, without any processing. You don't need to understand what happens in the model. You just need to touch this endpoint by yourself, and your attack will be successful. So that's where application security starts. I think adversarial attacks ends when application security starts. And sometimes you don't need to be the expert in machine learning. You don't need to waste your time as an attacker to train the model, to bypass the filter. But you just need to find one SSRF, and that's it. So that's why I'm going to talk about application security, and during some research, pen test, external pen test, maybe it's like personal research, including machine learning stuff. We think that the standard mistakes happens 10 years. The same vulnerabilities, different code, different languages, different frameworks, different skill set of developers, but the same mistakes. If you look at top 10 or ask top 10, something changed? Not sure. Just maybe names of the vulnerabilities, names, titles, but techniques of exploitation, techniques of finding the same. And I think the one main bug here in application security is in human DNA. Yes, we need to fix the human DNA. And that's why I think leading independent organizations like OWASP, Open Web Application Security Project, they decide not only to share with the people some methodologies, some tools, but also some programs like security championship programs. And it means that they try to fix not only the process of SDLC, yes, not only weaknesses in the process of software development lifecycle, but human factor in this lifecycle. It means that you need to prepare not a security dedicated expert in your team. You need to prepare security expert in each developer of your organization. And during some of the carriers, I think we have some experience to deploy this program, to implement the program, to understand the pain points. Is it how to teach your developer to be a little bit security ninja, just not to use SAST, DAST, or etc., but how to fix the code. So because if you fix the vulnerability and the latest stage of release, it means you will spend more money. You need to move to the left. You need to fix the vulnerability from the code. And only one solution that helps you to do that, it's the people who produce the code. Yes. Of course, you can organize the bug bounty program. You can organize the penetration testing, crowdsourcing for this problem, but it will be just a fixing of symptoms, not a root cause stuff. That's I'm going to talking about.
Well, I mean, when you talk about application security, I think a lot of times the developer mistakes, right, are simply because they're cutting and pasting shit from, Stack Overflow, right? So code examples that are given that already have bugs in them, and then, they're just reusing that, or it's libraries. And that's also another issue, right? Like, I mean, a lot of times we just leverage whatever framework, library, especially Python, right? Like you just, whatever, include the library. Let's import this, import everything.
Stack Exchange.
Right? But then, yeah, that stuff has vulnerabilities, and then you don't really think about it because you kind of pasted it. Now your entire app is screwed, right?
Yes, correct. And education of developer, it's a little bit different process than education of hacker, for example. If you see some try to educate yourself, you will see some deep technical programs that requires you to learn tools for attackers, yeah, that's something that's trivial. But developers, it's a little bit different mindset. So for developers, security is like one feature. Yeah, you don't need to open your burp suite every time when you produce the code, because you're a developer, you waste the money of company. That's why you need just to understand, is your code correct or not? earlier. So it's a different approach for the training programs for developers. And I think championship, it means that we don't need to prepare security experts, but we need to prepare development experts in security stuff.
Oh, sounds fascinating. Unfortunately, I think that's all the time we have for today. Sorry, Dylan.
Yeah, I just noticed the time actually.
Just for everyone to know, both Eero and Dennis, sorry, Dennis are having trainings next month with HITV SecTrain, courtesy of IT SecTrain. Do go to the website and check them out. They look to be pretty cool. They're just 4-hour lab sessions, but I'm sure it's full of information based on what you've just heard, right? I think, Dylan, you want to do a closing key for today? Well, not a key, just closing.
I say a few words. So yeah, hey, Eero and Dennis, thanks so much for joining us, guys. Looking forward to seeing your lab. I think that's happening next month, right? So I'm not sure what the time zone is, but it's on the website somewhere. So for you guys that want to learn more about, machine learning stuff and all these good things that Dennis was talking about, and Eero as well, they got a 4-hour lab. So that's going on next month, I think, next month or in July. So sign up for that. It's on the HITV SecTrain website, so you can go and take a look at that.